Good morning, good afternoon, and good evening. I'm Christine Stewart, IBM Analytics Partner Manager, and I'm responsible for helping our business partners infuse analytical capabilities from IBM from an analytics perspective into their applications and their services to better provide for their clients. On behalf of the IBM team, I want to thank you for joining us today. And I'm coming to you from the IBM headquarters here in Armonk, just north of New York City in the United States. I'm pleased to introduce Venki Rao, Chief Technology Officer on Predictive Analytics and Optimization Solutions here in North America. Venki has extensive experience in the predictive application sector. He's worked on both the sales and technical side and has brought leadership skills to both. Venki today will provide an overview of predictive analytics, the evolution of how predictive analytics came to be, and provide an understanding of how you can apply it to your business through an engaging whiteboarding session. Very excited, and we'll hand it over shortly to Venki just in a second. Before we get into the actual whiteboarding session, I'd like to share with you IBM's point of view from an analytics and more specifically, predictive analytics perspective. Predictive analytics has definitely become a major buzzword that some may ask, what is predictive analytics? What do you mean by predictive, and how can I incorporate that into my business? And that's what we're here to talk about today. Paraphrasing Gartner's Gareth Herschel, Research Director from the Gartner Group, predictive analytics helps connect data to effective action by drawing reliable conclusions about current conditions and future events. So, in essence, predictive analytics is not a noun, but a verb. It is the process, the tools, and the people required that contribute to bringing insights and pulling that from the data that's then turned into information, turned into insights that you can bring back to your business and infuse across different processes, people, implementations, and your solutions for your clients. So taking that information, taking those insights, and being able to make better decisions so that you can stay competitive within the marketplace and stay nimble as well, both of which are extremely important to remain on top of the competition. In Forrester's latest research, or release of their Predictive Analytics Solutions Review Report, the Forrester Wave, which was released in early Q2 2015, they ranked IBM as the top predictive solutions provider worldwide. We are thrilled with that announcement and very pleased to hear it. Even more importantly, the report emphasized the importance of predictive analytics. Forrester made an excellent analogy in the report and compared Cassandra to that of the data scientists. And to provide a little context, and to those of you that may not recall Cassandra from your Greek mythology classes, I'll bring you back to history from high school and college. In Greek mythology, Cassandra was the princess of Troy who was blessed with the gift of being able to foresee and predict the future. However, even though she had that ability, she was cursed so that no one would believe her. So unfortunately, when she predicted the Trojan War and the destruction of the Greeks, no one took her seriously. So she had the gift of foresight, but she was unable to use it. In Forrester's report, the report states, if organizations do not use predictions to change the future, then they're making their data scientists as helpless as Troy's Cassandra. And in essence, drawing the comparison from Cassandra to those data scientists being unable to use and analyze data to make predictions about the future. If organizations don't infuse those processes, those people, and importantly, those tools into their organizations. With that said, we're here to talk to you today and share with you from an IBM perspective the evolution of analytics and the importance of incorporating predictive analytics into your business and into your application solutions that you provide to your clients today. Venki Brau will break it down from a predictive analytics perspective through a whiteboarding session that's engaging, and it makes predictive analytics simplistic, yet very impactful and easy to understand. He will share IBM's perspective, an approach to incorporating business analytics and predictive analytics to your business, and an overview of our best-of-breed solutions as recognized by Forrester. So thank you again for joining us. We appreciate your time, and without further ado, I'd like to hand it over to Venki Rao, Chief Technology Officer for Predictive and Optimization Solutions. Thank you.
So let's talk about the evolution of analytics. So if you go back to the late 70s and the early 80s, when computing power started to catch up, IT departments started capturing pieces of information and putting them into a data warehouse. But if a business manager still wanted to use some of that information to drive decision making, he or she would have to reach out to the IT department, who would then extract the information in a programmatic fashion in some way, print out reams of papers, and then hand those papers off to the business manager. And then the business manager would have to look at those pieces of paper and then take the decisions based on that. One product changed all that, and that was Microsoft Excel. Because what Microsoft Excel did was it gave business users the ability to slice and dice data and play around with information. So information could be extracted into a spreadsheet format, and then business analysts and business managers could use Excel to drive some of their analysis. However, for anyone who's used Microsoft Excel knows that Microsoft Excel, while it's a great spreadsheet tool, is not necessarily the greatest enterprise-grade business intelligence tool. And therefore, fast forward a few years and to the early to mid-90s, you had companies like IBM Cognos that really spearheaded the business intelligence revolution. And what companies like IBM Cognos did was they provided a front end that business users could then use to access information stored in these data warehouses and slice and dice them any which way they wanted. So what business intelligence, the paradigm behind business intelligence was people interacting with data. Fast forward to today, where we're very much in a big data world with the advent of social media, Internet of Things, just the ability to capture more transactional information and so on. And we're now in a world where there's so much information that it's humanly not possible for us to identify all the relationships in the data. And therefore, if I were to adopt a simple business intelligence approach where I was slicing and dicing information, a lot of my biases as an analyst would creep into my analysis and not necessarily lead me down the right path. And therefore, we're seeing the next stage in the evolution to advanced analytics or predictive analytics. And the big paradigm shift here is, while with business intelligence, we talked about people interacting with data, with advanced analytics or predictive analytics, it's more math interacting with the data. So you have these sophisticated algorithms that go against all of the data, unearth these hidden relationships in the data that's just humanly not possible to identify, surface those relationships so that businesses and business managers can exploit those insights for the gain of the business. So if you look at this evolution, it seems fairly organic, and clearly Microsoft Excel is ubiquitous, it's everywhere, but business intelligence systems are also pretty much in every organization, both large and small. They have some form of a business intelligence system. Everyone does. Now, if advanced analytics or predictive analytics is so important, why is that not as widely adopted as business intelligence? Is it because it's new? Well, not really. These algorithms have been around for a very long time. If we're in 2015 today, and if you've seen the Imitation Game that came out earlier this year, you would know that Alan Turing was inventing a machine that could decode messages during World War II. So these algorithms and the ability to use machines to decode hidden relationships has been around at least since that long, if not earlier. But why hasn't this been as widely adapted in business? And there's really one simple answer to that question. And that is, if you look at these algorithms, they're certainly sophisticated. But they're not very easy to use. So ease of use is a whole different circle to the side of it, and there's a huge chasm in between. And because these algorithms have not been really easy to use, businesses and industry just haven't adopted them as widely as they have with business intelligence. They've been used in government and research and academia forever, but they just haven't been as widely adapted in business. One company has really changed all of that, and that's IBM SPSS. What IBM SPSS has done is it's taken these sophisticated algorithms and packaged them up in an easy-to-use form so business analysts with a deep understanding of the business problem that they're trying to solve can now use IBM SPSS without having the need for a PhD in statistics or the need to write lines and lines of code, and have them deploy these sophisticated algorithms against their data, identify these hidden relationships, surface them, and use that insight to solve their business problems. So when I present this to a lot of my customers, they ask me, why is predictive analytics so important? Do I really need predictive analytics? What's the extra edge that predictive analytics provides that a business intelligence software does not provide? To address that, I'm going to take you on a journey with me to Singapore, which is a beautiful island country in Southeast Asia, where I had the good fortune of spending a fair bit of time. Singapore, for those of you that don't know, is located 1 degree north of the equator. And as a result, Singapore has extremely predictable weather. Unlike Boston, where I'm from, which we tend to get a lot of snow and we get different seasons of the year, Singapore is just hot and humid all the year round. The other thing about Singapore is it rains every evening, pretty much every evening between the hours of 4:30 p.m. and 5:15 p.m. It rains in Singapore. It rains very heavily, like the world is coming to an end. And then 5 minutes later at 5:20 p.m., because it's so hot, the streets are completely dry and you wouldn't even have known that it was raining. The reason I take you back to Singapore is Singapore actually faced a very curious problem. So here's the situation. It's 4:30 p.m. We're at a taxi stand, and we have some people waiting around for taxis. And because it's 4:30 p.m., it's starting to rain very heavily. Unfortunately for our friends here, there are no taxis in sight. So they're not very happy right now. They're waiting at a taxi stop, but there's no taxis in sight, so they're not very happy. Unfortunately, this is not a one-off occurrence. This happens all the time, or this used to happen all the time. So what these people started to do was they called the taxi company and they started to complain. They said, when I'm at a taxi stand and it's raining, I can never find a taxi. So what the taxi company did in order to solve this problem was they adopted a business intelligence approach. So one of their analysts decided to look at the data that they had and identified 2 pieces of information that would be, in any reasonable person's mind, the 2 key pieces of information to solve this problem. And they were the population of Singapore and the number of taxis on the road. Now, as most of you folks will know, most taxi companies have some sort of an optimization equation to decide the number of taxis in their fleet. If the population is X, then the number of taxis is Y, and so on. And our analysts studied this information closely and decided that while the optimization equation was working for normal times, because most people didn't have a problem finding taxis during non-peak times, the optimization equation was clearly off in peak times. And clearly, when it rains, it was peak time. So based on this analysis, our analyst suggested to his management team that the taxi company actually buy new taxis because the optimization equation was off for peak times. Now, this analysis withheld scrutiny, went up the chain, and the decision was made to increase the number of taxis on the road. So this is the action that they took based on the analysis. So increase taxis on the road. Let's think about the consequences of this decision for a second. And the most important consequence of this action was that the average income of the taxi drivers dropped. Any student of economics will tell you that price or income is dependent on demand and supply. In this case, the population of Singapore did not change overnight. It stayed the same. But by increasing the number of taxis, this went up. So there were a whole lot of taxis that didn't really, that was just a result of the action that the taxi company took. It wasn't really dependent on changes in the population. And as a result of this, the average income of the taxi driver dropped. Now, it would have been great if this problem was solved, but after 3 months into this experiment, unfortunately for the taxi company, these calls did not stop. So not only did they have angry customers, they now had angry employees as well. So what seemed like a big problem ended up being compounded by a perfectly reasonable approach. Now, I'm a huge science geek, and I'm a big Stephen Hawking fan. And Stephen Hawking has a really powerful saying where he says, the enemy of knowledge is not ignorance. The enemy of knowledge is not ignorance, it's the illusion of knowledge. And this saying struck me very deep because I started to think about all the times in my life when I took decisions based on what I thought was right, but in fact, when I look back at the consequences of those decisions, it wasn't really the right decision. I just thought it was right, but it wasn't really right. And this seems to be the exact same case with this taxi company in Singapore. This was very much the illusion of knowledge. They thought this was the right decision, they took it, and the consequences, did not turn out to be the way they expected it to turn out. But what this company did was they said, well, we still have to fix the problem. In fact, we've just gotten a bigger problem now, but we should certainly try and fix this problem. So they went ahead and they adopted an advanced analytics or a predictive analytics approach. And they hired a data scientist to look at all of this data and run it through a bunch of algorithms. So what this data scientist did was he collected a ton of information. He went ahead and collected information on weather patterns. He collected information from the GPS devices that were loaded in these taxis. Just went ahead and collected a whole lot of additional information that was not available to the taxi company internally. And he ran all of these new additional data points through a bunch of algorithms. And what he found out was some very interesting but counterintuitive insight. He found out that when it rains, taxis stop. That was really counterintuitive. Think about it this way. If I were a taxi driver and I wanted to maximize my income, I would always ply my trade during peak times. I would always drive my taxi when there's high demand for it. Certainly when it rained, there was high demand in Singapore. So when the data suggested that when it rains, taxis actually pull over and stop, that was completely counterintuitive to what they expected. But the interesting thing about it, though, is using advanced analytics, they were able to identify exactly what the root cause was for why people weren't getting taxis when it rained. They were able to find out that when it rains, taxis stop. And if taxis stop, people don't get taxis when it rains. Now, so what they did, of course, using this crucial piece of insight, they fixed the problem. They changed. What they did was they decided to figure out why people are pulling over and stopping when it rains. And upon talking to some taxi drivers, they identified that the company had a policy where they would withhold $1,000 from every taxi driver's income if that person was involved in an accident, irrespective of whether it was their fault or not. Once the insurance company actually settled the claim, they would refund this money if it wasn't the taxi driver's fault. But just the fear of having $1,000 of their salary withheld by the taxi company was enough for them to pull over and stop when it rains, because obviously when it rains, the road conditions are treacherous and it's not safe to drive. And therefore, the likelihood of getting into an accident goes up significantly. Now, once they were able to identify this, the taxi company changed their policies. And today, when it rains in Singapore, in taxi stands, you have happy customers in taxis, but no people standing around. And here is a true story of why predictive analytics is so important. So coming back to Stephen Hawking's quote, where the enemy of knowledge is not ignorance, but the illusion of knowledge, you can see that this quote is really applicable to this situation, because using advanced analytics, we were able to get to the root cause of the issue and solve it, thereby moving from illusion to knowledge. And that is why predictive analytics is so important. Now that I've mentioned predictive analytics a fair bit, and I've talked about why predictive analytics is important, let's demystify predictive analytics and truly understand what it means. And from my perspective, predictive analytics is a verb. It's something that you do. It's not a noun. It's a verb. And therefore, I think of predictive analytics as a process. So let's talk a little bit about the predictive analytics process. The first part of the predictive analytics process is actually capturing data. And that's a great place to start, because data mining is one of the techniques that you use for predictive analytics. And obviously, you can't do data mining without data. So capturing data is a great place to start. So the first part of our predictive analytics process is capturing data. So let's call this the PA process. What do we mean by capturing data? What does data itself mean? Data means different things to different people. When you talk about an Excel spreadsheet, people start to talk about unstructured data. So in order to make sure that everyone's on the same page, I like to use a data triangle to look at the different dimensions of data. So on one corner of the data triangle, we have sources of data. And these could include traditional data sources, such as Excel spreadsheets, CSV files, relational databases, and so on. And we also now have big data sources. So things like Hadoop, NoSQL systems, and other analytic data stores. On the other corner of the triangle, we've got forms of data. So data could be data at rest, which is what most of us are very familiar with. Most of us deal with analysis on data at rest, which refers to transactions, which refers to data about transactions that have already occurred and have been stored somewhere. But more and more, we're seeing the application of data in motion. And we're seeing the application of analytics on data as it's coming in. And this is starting to get more and more important. Let me give you an example. If I were a bank and I had a credit card customer, I would like to be able to identify a potentially fraudulent transaction on that credit card as it is happening. Because then I could block that transaction, call my cardholder, and inform them about it so they could validate pretty much in real time if that transaction was fraudulent or not. If I did not have the ability to do this, I'd have to wait for the monthly statement to come along and then call them up and say, I think there was a fraudulent transaction that had occurred. And that's not really useful for the customer. And that's just one example. There are other examples of data in motion becoming more and more relevant in healthcare and manufacturing and so on. On the third part of the triangle, or the third corner of the triangle, we have types of data. And this could include structured data, which is data that resides in rows and columns, and unstructured data, which includes things like emails, text messages, Twitter feeds, Facebook, video, and so on. Now, most companies are still just mining structured data, and that's a great place to start. But given that only about 20% of the world's data is structured, whereas 80% of the world's data is unstructured, and that unstructured data is growing at a much faster clip than structured data, more and more companies are starting to mine unstructured data because there's huge amounts of knowledge that are stuck within unstructured data that you need to be feeding back into your analytics process. Because if you're not doing that, with 80% of your data, you're leaving money on the table. So you've got to make sure that you can analyze unstructured data as well. So when we're talking about capturing data, we're talking about capturing different forms of data irrespective of whether it's at rest or in motion, whether the data is structured or unstructured, irrespective of where it's stored. You have to have the ability to mine all of this data. The next step in the predictive analytics process is actually making predictions off of that data. And in order to do that, we use tools like data mining, text mining for unstructured data, as well as statistical analysis. And if you look at the predictive analytics industry today, this is the hottest area that everyone's focused on. Established players like IBM, as well as startup companies, are constantly looking to innovate in this area, provide more user-friendly tools for analysis, build more sophisticated algorithms that perform better on big data, and so on. And while that's great, if you simply stop there but don't act upon the insight that you've gained, it's like strapping on a parachute to your back and jumping off a plane, but then not deploying your parachute. You're going to crash and die. And therefore, the third part of the predictive analytics process is actually acting upon those insights. And in order to do that, IBM has a whole suite of deployment technologies that let you take the insights that you've gained through the predict process and deploy them into operational processes at the point of impact. So you can influence these decisions as and when they're happening. Now, one of the reasons that IBM has been rated as #1 in the latest Forrester wave of predictive analytics platforms is because we have solutions that span the entire predictive analytics process. Whether you're looking to just enhance your data set by capturing additional data sources, making predictions off of that data without writing lines of code or without needing a PhD in statistics, or actually deploying those insights to influence your business and impact your business in a positive way. So let's take a look at our suite of solutions that address each of these three areas. On the capture side, we've got SPSS data collection. SPSS data collection is the most widely used data collection software in the market today. Whether you're the largest market research company in the world, or just a company that wants to survey their own employees, or hospitals that want to survey their patients to determine satisfaction levels, SPSS data collection is used everywhere. So if you want to go ahead and enhance your data set by going out and collecting employee opinions or customer opinions, you could use SPSS data collection to do that. We also have social media analytics. That lets you mine social media like Twitter and Facebook and identify how the public or how people outside your company perceive your company and your brand. Is your brand perceived positively? Is it perceived negatively? Is your brand getting the share of voice, or is a competitor's brand getting the share of voice, and so on? And social media analytics lets you do all of that. On the predict side, our enterprise data mining workbench is called SPSS Modeler. SPSS Modeler is the most incredible piece of software. It's a revolutionary tool that packages all of those sophisticated algorithms that I was talking about into a user-friendly, easy-to-use graphical user interface. So any business user can use SPSS Modeler to mine data sets and build very, very sophisticated models with just a little bit of training. We also have SPSS Statistics. If you've ever taken a statistics course in school, you've probably used SPSS Statistics. It's the most widely used statistical analysis software in the market today. And we also have the truly innovative Watson Analytics, which is available on the cloud and lets you very quickly explore your data, make predictions off of your data, and visualize them and package them in the form of dashboards that you can